Okay, thanks everyone for joining. We will begin in about a minute or two while we wait for the rest of the people to just join us. So just kind of sit back and relax, and we'll begin shortly. Thank you. Okay, good morning, good afternoon, good evening, everyone, wherever you are joining us from, on Zoom and also on AngelHack's YouTube channel. Welcome to day 3 of workshop that is happening alongside the Avalanche Hacks Summer 2022 Hackathon itself. Before we begin for today, first of all, I'd just like to thank all our sponsors who help support the hackathon itself, the Graph Foundation, QuickNote, CertiK, and also ROK Capital as well for helping to chip in terms of getting this hackathon up and running as well. Just a quick overview of what the Avalanche Hacks Summer 2022 Hackathon is as well. The goal of this hackathon is really about visiting the disruptive technologies such as GameFi and DeFi as it's continuing to gain momentum in the Web3 scene. So this hackathon itself is really about focusing on how you can solve challenges in both DeFi and GameFi using Avalanche. So there are 2 main tracks for you to actually participate in terms of working for your project submissions. First of all, it's the DeFi track where the goal is actually to utilize Avalanche's technology to create DeFi dApps and toolings and infrastructure to attract and onboard the next wave of DeFi users as well. The second track, which essentially is GameFi, it's all about leveraging the power of Avalanche to explore new mechanics and for Web3 gaming to create a fun and interactive experience for gamers. Essentially, this track in itself does not require you to actually submit a game by itself, but you can actually focus on developing certain elements of the gaming ecosystem for your project submissions as well. On top of that, there are actually sponsors bounty that you can work on from QuickNote, the Graph Foundation, and CertiK have all contributed to bounties which you can work on and submit alongside with your main tracks project submissions as well. With a prize pool of USD 55,000 plus, this is a hackathon that you do have quite a fair bit of prize amount that you can kind of grab yourself. And most importantly, for all the participants for the hackathon that I would like to drop as a reminder is that regardless of the complexity of your idea, all project submissions are actually welcome for this hackathon because the Avalanche ecosystem is really one that focuses on different builders coming in with different experience and knowledge as well. So before I pass the time to today's speaker, just a quick reminder for all of you there tonight that if you have any questions with regards to the workshop sessions, questions about CertiK or any questions about the hackathon, please feel free to drop them on the Q&A box. And for those who are joining us live on YouTube channel, you can drop them in the chat box as well, and we'll get to them towards the end of the session. So without further ado, covering the topic of top 5 vulnerabilities and exploits, we have David Tarditi, Vice President of Engineering for CertiK. David, the time is yours.
Okay, great, thank you. So first, I'd like to thank everybody for attending this workshop. I'm going to talk about vulnerabilities and exploits and talk about our experience, what we've observed are top vulnerabilities and exploits. But the point of this talk is really to help you guys understand security and how to bring security to your projects and how to think about it. So in terms of the outline today, I'm going to talk about like, why does security matter? Talk about some recent DeFi hacks and their impact. I'm going to talk about top vulnerabilities. So how did we identify them and what are they? Then I'm going to do a deep dive into one vulnerability we call centralization risk, which some of you may have heard about. And then I'm going to step back a little bit and talk about, well, how do you avoid these vulnerabilities and exploits? I'll talk about some best practices for Web3, the general context of how to think about security for Web3. And then I'll dive into some best practices for smart contracts. So in terms of recent DeFi and GameFi hacks, the hacks and exploits total up to $1.3 billion just in 2021. And 2022, even though we're not done, is already worse. So this is the total value lost to DeFi hacks in 2021. And so, you can see we start off a little slow, but by halfway through the year, almost $500 million has been lost. And by the end of the year, we're up at $1.3 billion. So there's a lot of money at stake. It can impact your project. It can impact your end users when you get, if you have a vulnerability and you get hacked. So there's some examples of hacks and why they're sort of difficult to counter. So in April of 2021, Uranium Finance was hacked for $50 million. And this was omission of a single character. So I think they did an upgrade of their project and they were increasing a constant factor and they left out a digit in one place where they were increasing the constant factor. And then Compound Finance was hacked in October of 2021. And these are just samples of things. And they gave about $90 million in unearned rewards. And it was a one character mistake. They wrote a greater than instead of greater than or equal to them, greater than or equal in their contract. The DeFi protocol BZX was hacked for $55 million in November of 2021. So in this case, this was a phishing attack. The developers phished by emails, their keys were stolen, their mnemonic seed phrase was stolen for their Polygon and BSC deployments. And once the attacker had that, of course, they had control of the protocol. And then, so if we step back and look at 2022, we've seen Qubit Finance, we've seen Wormhole, we've seen Meter.io. We saw Ronin get hacked. That was sort of a GameFi style hack. And it's been more than $1.7 billion. And I computed this back in like June or something, so I'm sure it's gone up since then. So anyway, so this explains why security is important. There's a lot of money at stake. When you have that kind of money at stake, you're going to attract hackers. Identifying top vulnerabilities. So CertiK is the leading blockchain security company. We've done thousands of smart contract audits. I think in the past 12 months, we did at least 2,400 audits. We analyzed our audits for a 6-month period to identify common vulnerabilities. So in terms of how we did this well, like I said, CertiK is the leading blockchain security service. So we provide auditing, formal verification, security leaderboard, and there's a typo there. It should be a KYC service. We audit everything from the blockchain implementations themselves to smart contracts. Obviously, the larger volume of audits is around the smart contracts. We looked at audits for 1,427 projects from September of 2021 to February of 2022. We analyzed the types of issues found during these audits. So some of you may not be familiar with how a source code audits. I'm going to go over that right now so you can understand what was involved in looking at the code. And so this is how CertiK works to secure your source code. So the project team provides us the source code. Ideally, they do this before they have published to mainnet or an active network, a production network. CertiK security experts will review the code and will also run analysis tools on your code. And we will provide a written report with issues. This diagram here shows what kinds of things would appear here on our leaderboard. So we have different kinds of issues. we rate them by the severity of the issue, and the severity is really sort of what's the potential risk and what's the potential impact. We rate things ranging from informational, like this would be nice to do, you should clean up your code, maybe it would make it easier to read, or it might save you some money in terms of gas optimizations, to minor, which is like, hey, this is something you should fix, but it's, maybe the amount of money that could be lost is limited, or the impact could be limited, to all the way up to critical issues. And if you see a critical issue in an audit report, that usually means like, hey, if you put this out on a production network, you're probably going to get hacked, and you might get hacked very quickly. So anyway, and what we do at CertiK is we actually publish these reports when you're done. But anyway, so after we do this initial report, we give it to the project team, and the project team and security experts discuss the report, and the team can fix or acknowledge the issues. We may do several rounds of discussion just to clarify things or understand stuff or see your fixes. And then when we're all done, CertiK publishes the final report at certik.com. So like I mentioned, we were looking at over 1,400 projects in this analysis of vulnerabilities. We found 16,400 issues in the projects, and of those 16,400 issues, 5,300 were rated critical, major, or medium severity vulnerabilities. So we looked at those issues because these are the issues that are going to have the biggest impact. And here's what we found. We found that the leading vulnerability that we observed in our audit reports over that time were centralization risks. And so an example of that is the owner can update rewards balances, and we found 3,000 occurrences, over 3,000 occurrences of that. The second thing we found were logical and correctness issues. So an example of that might be incorrect calculation of rewards, or maybe a math error somewhere, or a rounding error. Then we also, after that, we saw withdrawal issues. So these are cases where your money or the value can get locked in the contract. So it might be that it's possible for somebody to set a parameter so the contract jams up. It might be that the contract has no way of letting you actually withdraw your money. The fourth issue that we saw was what we call access control. So this is, if you have somebody, if you have an administrative account, maybe you didn't actually enforce checking that it's somebody with administrative privileges doing a high impact operation like calling mint. So lack of access control is a pretty significant issue or vulnerability if you see it. And then finally, we saw lacks of limits on bounds or fees. So lacking limits and bounds. So, when you write your code, you need to think somewhat defensively. And, you might want to make sure, for example, if you're going to use a smart contract, you're the consumer of a smart contract, what percentage fee can the owner set on that contract? And so it's best, the owner may say, hey, I'll never, or the project may say, hey, we're never going to set it to more than like 3% or something. That should be in the code. And if it's not in the code, of course, there's no guarantee that something won't happen or that a hacker won't get a hold of this stuff and be able to take advantage of that. So I'm going to jump in and talk about centralization vulnerabilities, since this was the leading set of issues that we saw in terms of during our audits of contracts. So a centralization risk, it's a case where a privileged role, such as the owner, has control over one or more sensitive contract operations. So some examples of centralization risks that we've seen. Extreme one is the privileged role can update user account balances without any restrictions. That's not good, because if somebody loses control of the keys for the privileged role, that means a hacker can update the accounts and basically take your money. Another one we see is withdrawals. So this is a case where maybe they have like an emergency withdrawal function, but it says I can take the value locked in the contract and send it to an arbitrary address. Or a less extreme version might be I can withdraw all the rewards. We've also seen issues around initial token distribution. So maybe when the contract is first deployed, maybe all the tokens are sent to the contract deployer, the externally owned address. So that's problematic because maybe if your project has a governance component, it might mean that somebody holds enough of the value that they basically control governance. You know, and the risk there, of course, is somebody dumps those tokens. It can drive down the price, cause a loss for your users, cause problems for the project. We've also seen risks around contract upgrade. This one is a mixed issue. You know, you want to make sure that if you have a contract ability to upgrade the contract, you have some control over the contract upgrades. Maybe you want to have a time lock or something. You want to have community governance, a DAO or something about this. But the problem is if you have a contract upgrade and it's just completely uncontrolled, again, an attacker who gets hold of the privileged role can upgrade the contract to one that basically takes most of the money. And then a final thing we've seen, I mentioned this, was setting key parameters of the contract without limits. Okay, all right, so let's see. So there was a question here about what is the median cost for CertiK to perform an audit on, for example, a DAO, a very common contract. I can't really speak publicly about the cost, but there was a question about what's the median turnaround time for the final audit report. You know, some auditors have a fairly long backlog. It really depends on the size of what we've been asked to audit. So, you know, if it's a fairly simple contract, we can generally, you know, get that queued in a couple of weeks and complete the audit in a couple of weeks too, a week or two. If it's a longer or more complex contract, it might take us a longer time to do that. There's sort of software laws of physics. You can only review code and understand complex code so fast. And so putting more people on it doesn't necessarily, you know, make you understand the code better. So it does vary, but typically, you know, our audits may take us, you know, three days to 90 days of effort, depending on the complexity of the contract. And like I said, we can generally get the smaller contracts scheduled fairly quickly and turned around pretty quickly. And the cost is proportional, of course, to the difficulty of the audit. So, so yeah, I hope that answers the question there about audits. So, you know, coming back to the centralization risks, you know, the whole point of centralization is you have one, a privileged role that has control over important aspects of the contract. And so, you know, the thing about centralization is it's sort of the opposite of DeFi. You have to trust the privileged role, not the code. And that can be problematic. So to give you, dive just a little bit deeper on centralization risks, typically what you do when you approach this is you think about what we call a threat model. So it's like, and I'll get into a little bit more about threat models later on, but it's like basically like what could go wrong? So, you know, two threats to projects related to centralization risks, you know, one is leaking the private key for the privileged account. And so you hear about this sometimes, like the BZX thing was basically that kind of problem. The consequence of that threat is that the hacker now has privileged power, and so they can sort of do whatever the project owners could do. And so, you know, then the question is, you know, what can you do to fix or mitigate this? Well, the best thing to do is to remove the functionality if you don't need it or implement it in code. You might want to, if you've already deployed the contract, you can renounce the privilege role. If you have a private key, strongly advised to use a multi-signature wallet and a time lock, or to have another contract control the functionality instead. And you can also use a DAO for community approval. So you can make sure that it's not something that a few individuals can do. Another risk is, you know, an internal operations or rug pull risk. And so this is a case where maybe, for example, it's happened where only one person knew the key, and then that person passes away or ends up in the hospital. or maybe there's an insider attack. And the consequence of that is that token holders lose all their money. And again, we think about this in terms of fixes and mitigation. So best approach is, remove functionality that puts you at risk or implement it in code. Another approach, sometimes people need the functionality to get the project started. After you get the project started, you can renounce the privilege role. CertiK actually offers a KYC service. So we will, it's a know your customer service. So we can KYC the owners without the owners being doxxed. So we'll go in and do a background check, a fairly rigorous background check, and a check that the project participants are who they say they are, and they don't have any problems in their background. And of course, finally, you can use a DAO for approval. So I'm going to talk a little bit now about best practices for Web3. So I talked about sort of what can go wrong. I've talked about some leading vulnerabilities. Now I'm going to talk about, how do you avoid creating a project or creating a code with these vulnerabilities. So the thing about Web3 that makes it interesting is that it's more than just the smart contracts. Typically you might have a website or something, a game or something operating on the internet. And the thing to understand about securing your Web3 project is that hackers are going to go after the easiest targets first. So like you'll see these kinds of attacks. You'll see people socially engineer the users. So people make, their Discord server might get hacked. They might, hacker might take over the Twitter account and then direct people to a bogus website. Maybe there'll be a message posted somewhere about, hey, here's a free airdrop of tokens. Hey, just click on this button over here. So hackers will just go after the easiest target. If it's easier to socially engineer your users, that's what they're going to do. More sophisticated hackers who are technically more sophisticated may try to attack the web UI front end. So, if there's some kind of web UI and it says like, click here to grant permissions so I can link to your wallet, well, if you can compromise the web UI, the web front end, you can grant permissions to the wrong person or the wrong account. Hackers will try to compromise the private keys or passwords. I call this operational security. So they'll try to phish the project members. And then finally, the harder things are finding flaws in smart contracts or targeting bridges or blockchains themselves. And so, for example, the Ronin hack was actually an attack on a blockchain that the Ronin community had, or the Ronin project had implemented. They actually hacked the project bridges, the validators on their bridge, which was a separate blockchain. There were only 9. They managed to get onto the machines. They managed to get hold of the private keys, and then they were actually able to compromise that. So I know you guys are here to hear about code, so I won't go on too long about Web3, but you need to watch out for being phished or socially engineered yourself. So by all means, secure all your devices, turn on your biometrics, turn on screen lock, make sure audit updates on. For example, Apple just had a 0-day that was published. If you had an Apple device, an Apple iPhone or an Apple computer, it basically applied to almost all of them. They had a problem in the kernel related to some hardware acceleration. So, the fix for that is get the update as quickly as possible. If you have account recovery, for example, for social media or for access to GitHub or something, make sure you have a different email for account recovery than your usual email so that you will know if something weird happens and it's a little harder for the, if the hacker gets hold of your main email account, there's still this other email account with a different password. Enable multi-factor authentication. And as a project, make sure you have documented procedures for verifying unusual or high-risk requests. If you get, I get messages all the time of, hey, this is wrong way, could you do something? And it's like, I know to ignore them because that's not the way Wrong Way would communicate with me. Wrong Way Gu is our CEO. So make sure, if there's somebody says, hey, I want you to approve an emergency update to the contract, click over here. That's not something you really want to do. You also want to avoid social engineering of your users. So make sure, you have official social media channels. People post things like, hey, our Discord is down, we want you to go over here. Make sure that people understand, no, this is really your official Discord server. This is what you should use, or this is our official Twitter account. And having multiple of them helps people cross-check. Use multi-factor authentication to protect your accounts and secure your website. And then finally, for protecting your private keys and passwords, always use multi-signature accounts to control the smart contracts in your project. You always want to make sure it avoids a single point of failure. And you always want to make sure that it also makes it much harder for an attacker to compromise the projects. And really, you should be using like hardware devices for storing your blockchain private keys, like storing them in MetaMask in some team members' browser is really not a good practice. So anyway, that's a little bit about the Web3 side. The important thing to understand is that when you're building a Web3 project, the hackers have a broader attack surface. They're going to go after whatever is easiest for them to do. So let's talk a little bit about smart contracts and how to do that. So the first thing is smart contracts, they're programs. So you want to follow best practices for software design and implementation. There's a set of specialized practices for writing secure code that you also want to follow. And then finally, you really, once your project gets closer to production, you want to get a source code audit. So, and repeat that source code audit if code changes. And so in terms of following software design and implementation best practices, make sure you write a white paper or design document. You don't want it just to be something informal that people have discussed. And this is a typical practice that you'll see on most projects. They'll have a white paper. Some of them may have a yellow paper that goes into more detail about the implementation or something. Make sure that you do write a white paper or design document. And I'll explain when you're doing the secure coding aspect, it's important to have that design. Use code reviews while developing code. So, when you have a team of people writing code, even if it's just you and one other person, always use code reviews. Make sure that somebody else is looking at the code. Every person brings a different perspective to the code. They can see things that you might miss. Basically, a team of people is better than just one person. So make sure you're using code reviews and that you're responding to them. If your compiler is giving you warnings about, hey, you're doing something, you shouldn't do this. Hey, this code seems dead, or hey, this condition in your if statement is always true, or there are any other complaints, fix the compiler warnings and use static analysis tools. So Avalanche is using Solidity. So there are tools like Slither out there that you can go get. So make sure you're using these static analysis tools. And then I think last, but certainly one of the more important things is write tests for common and corner cases. So, you want to write tests for what is supposed to work, your common case, your best case, what the user is doing, but you should also write tests for what is not supposed to work. And you should write tests for corner cases, like suppose somebody asks to withdraw a very large amount of money. Maybe they're trying to provoke an overflow in your code. Suppose somebody gives you a negative number. You want to test both what is supposed to work and what is not supposed to work, and make sure that when it fails as expected. So in terms of secure coding, you also want to follow best practices there. So you want to create a written threat model. So there's a lot of information on the internet about threat models. The idea is basically to have the architecture or implementation of your project written down somewhere. And then in the threat model, what you do is you talk about what could go wrong. So you want to look at sort of worst case things that could happen. It could include, project owners lose internet connectivity temporarily. It could include loss of keys. It could include like, hey, what happens if something goes wrong with this contract? If you're depending on another contract or you're depending on another service, what happens if something goes wrong with that? You basically are thinking about worst case scenarios. And once you do that, you have an idea of sort of what your threats are and what's involved and what's at stake. You can prioritize them and change your implementation and use mitigations. So we went over an example just a few slides ago for centralization risk. And you want to follow good programming practices for smart contracts. So if you our programming in Solidity, the Solidity language website has advice about common patterns to use when writing code. They also have advice about security considerations. So for example, one problem, we don't see too much of it, but it can happen, is reentrancy. So there's good advice there about how to handle reentrancy, avoid writing code subject to reentrancy. You definitely want to follow good programming practices for smart contracts. And then finally, get a source code audit. So this is important before releasing code to production. If you're running a project, I know you guys are in a hackathon right now, so you're trying to be really creative and just build new stuff and build it quickly. If your idea, you think it's working out well, you're going to go to production, be sure to block out time on your schedule for an audit. And when you do the audit, make sure to provide your tests to your auditors as well. Security experts have likely seen your type of code before. And so they know where the problems tend to be. And so they have a lot of experience, can bring it to bear. You write one instance of your project, and maybe, if you're a developer, you work on a couple of projects in a year. These experts are reviewing dozens of projects a year, and can know what the common pitfalls and problems are. And finally, you want to repeat the source code audit if code changes. So with that, I haven't had a lot of questions. I'm going to slow down here and see if people have questions for me at this point. Okay, what about token economy hacks? So that's part of doing the written design document. You should be talking about the tokenomics of your system. Yeah, I was guessing it was for DeFi stuff. So there are a couple of things there, but you should in your design cover token economy. I don't know if you're talking about so if you're talking about tokenomics, that should be covered in your design document. Sometimes in our audits, we cover the tokenomics if we think it's a risk. Sometimes we don't. But you should definitely write down. And I guess my comment would be, you should try to get some peer review on your design. So get people, other people who are experienced, to look at that. To look at the token economy hacks. And the kinds of things that I think, we do look at things. Let's see. Okay, so I see more questions appearing. Good. The kinds of things we do look at. Are going to be things like I mentioned initial token distribution. So you kind of want to look at the governance. We will look at governance, like what's the threshold for making a change. So the kinds of things we will look at, like initial distribution. We'll look at is there any kind of accumulation of tokens to either whales or to project owners? What's the accumulation? A lot of projects have like built-in rewards for the project team. I mean, the project team needs an incentive to do this. And so you want to look at the fees. You want to look at the limits around the fees. We actually will take a look at the vesting schedule. Some people will say, oh, this is our vesting schedule, but it's entirely reliant on a person doing the vesting. It's much better if the vesting schedule is actually implemented as part of your project. So anyway, those are the kinds of things that I can talk to you about token economy hacks. There are also other kinds of hacks, and this is the kind of stuff that you want to get an auditor involved with. There's things called flash loans. There's people can mount a flash loan attack. They can basically borrow money and return it in the same transaction. If you're calculating value of anything dependent on if you're counting value in the same transaction, like you're saying, oh, I'll calculate value by looking at total value divided by number of tokens, and somebody can figure out a way to either create more tokens or a way to alter the value. You can be vulnerable to a flash loan attack. There are also things like front running that you have to worry about. That's less of an issue on Avalanche because it's so fast, but it can happen. Avalanche is really fast, so front running is less of an issue. So anyway, I hope I answered your question. If you have more, feel free to type some more into the chat window. Somebody else asked, can you take a moment to give a beginner like me an idea of the roadmap to becoming a Web3 code auditor? There's a couple of things you can do. The first thing is you want to understand and master the basics of programming a smart contract. So make sure you go off and learn about smart contracts, how to write a smart contract, how to test one, how to debug it. The other thing you can do is actually learn about the security practices. So you can read, all of our audits, for example, are public. So you can read those audits and see, like, could I spot this issue? What kinds of issues are people doing this? If you have the opportunity to take a cybersecurity course, that is also really helpful. Learning how to think in an adversarial manner is helpful. So the three things I would call out is, one, make sure you learn the basics of smart contract programming and understand that. Two, learn about the security aspects of things. So there's a lot of good resources. Learn about, what can go wrong in code. Try to read code, study audit reports. And the third thing is, if you get a chance to take some courses on general cybersecurity, that would be helpful as well. Let's see. So I see more questions appearing here. I've got to scroll down. Okay. Why is it that CertiK does not provide solutions to vulnerabilities in projects reviewed, but only points out those issues? So so Harish from AngelHack would like to answer that question live. Sure.
No, David, I'm just moving them to archive. Please go ahead. Sorry.
Oh, okay. All right, sure. So actually, CertiK, this is one of my points about the code auditing process, is we prepare a preliminary report. And in the preliminary report, we will point out the vulnerabilities, and we will discuss usually how to address them. So we will, every project, has their own specific goals. So we will give people advice or give them information. But typically, we have a discussion, and we help people. A lot of times we point out a vulnerability, and project developers are like, oh yeah, we see that, we've got that. But if they're having trouble, we will actually have discussions with them, or if they're not understanding the vulnerability, we will have discussions with them. So we do this preliminary report, and this is done privately. The preliminary report findings will go into the final audit, but if you read our audit, we'll say, like, this problem was resolved or this problem was mitigated. So we actually do work with people to provide, help them fix vulnerabilities in their projects that they review. Okay, so any more questions? I really appreciate everybody joining us today. And so thank you. If you're interested in learning more about CertiK, you can go to our website, certik.com. If you want to get in touch about an audit, you can email us at bd@certik.com. Yep, thanks for posting into the chat our website. So thank you, everybody. And also, feel free to reach out to us if you have any questions. We're happy to help.
All right. Thanks, David, for bringing us through the content for today's workshop and also answering some of the questions today as well. Just a gentle reminder for the folks who are actually participating at the hackathon. Tomorrow itself, there is still another mentor office hours. Please secure the opportunity to actually lock down a 15-minute slots with the panel of mentors who are readily helping you as well. Similarly, if you have any questions with regards to security or how you actually write your code just to ensure that you do have all considerations when it comes to security concern, you can also drop the questions at the CertiK channel, which is actually on the hackathon channel itself, or any other questions related to the hackathon. You can drop them in any of the respective help desks accordingly as well. And the mentors will actually get those questions as soon as they can as well. So other than that, thank you all for joining today's session. Once again, good luck to all participants of the hackathon and happy hacking. Thank you, everyone. Good night.